Welcome back to another day of notes. We're going to go over kind of everything we've done. So our absolute values, our inequalities, our absolute value plus our inequality. And this time we're also going to add on a few word problems. Okay. We're going to take a look at example 2 that's in this top section that says solve each question and check your answers. So on your homework, if anything comes from this section right here, check your answer. That's part of your homework too. First up, I got to get the absolute value by itself. Got that 6 in the way, so the opposite of my positive is negative, so I'm going to subtract 6 from both sides. My 6's cancel out. I now have 9 minus 6, which gives me positive 3. I'm going to rewrite everything else. That's my absolute value of 3 minus w times 1/2. Okay. Next up, I'm still trying to get the absolute value by itself. Right now, it's being multiplied by 1/2. When I'm working with fractions, I multiply by the reciprocal. That means I flip my fraction upside down and I multiply by that. So instead of 1 over 2, I get 2 over 1. Or another way of saying 2. So I'm going to multiply both sides by 2. Now what this does is it divides out my fraction over here, so that's gone. Just left with that absolute value of 3 minus w equals, my 3 times 2 gets me a positive 6. Okay. So I've got the absolute value by itself. That's the first step. Second step, I end up with 2 equations. Never forget that. 2 equations, 2 solutions. Okay. First one, I write with a positive solution. So my equations are always just whatever is inside the absolute value. And then one solution is positive. And one solution is negative. So our 2 equations are 3 minus w equals 6 and 3 minus w equals negative 6. Final step, I just got to solve both equations, which means I'm going to subtract 3 in both equations, still the same process for each. My 3's cancel out on the left-hand side, and then 6 minus 3. So I get negative w equals 6 minus 3, which is positive 3. And then negative w equals negative 6 minus 3. 2 negatives. I add my numbers. I keep the sign, so I get negative 9. Okay. Almost done. I almost got w by itself. Last step, divide by negative 1. So my negatives divide out. I get w equals 3 divided by negative 1 is negative 3. Same thing over here, w equals, and then negative 9 divided by negative 1 is positive 9. So I've got my 2 solutions, w equals negative 3 and w equals 9. Okay. So I'm going to make a bit of room. We've got all this down and make a bit of room so we can check. So my 2 solutions were w equals negative 3 and w equals positive 9. Those are my 2 solutions. Now I got to take my solutions and plug them back into the equation to see if they work, yes or no. So this one we're going to do the negative 3. Okay, so that's this one right here. That means I get 1/2 times the absolute value of 3 minus negative 3 plus 6, and then it should equal 9. So whatever's on the left-hand side should equal out the right-hand side. So I get my 3 minus negative 3, that's the same as 3 plus 3. Now I get 1/2 times the absolute value of 6. So rewrite a few things here. Okay. 1/2 times the absolute value of 6 plus 6 equals 9. Let's keep going. So absolute value of positive 6 still comes out positive 6. So this is 1/2 times 6 plus 6 equals 9. Half of 6 is 3. Same thing as dividing by 2. So I get 3 plus 6 equals 9. And we know 3 plus 6 is 9. So it's going to say 9 equals 9. So our negative 3 checks out. So I was checking for negative 3. Now we're going to check for our solution of a positive 9. This is my positive 9 solution. 1/2 times 3 minus 9 plus 6. And it should still equal 9, right? So my 3 minus my 9 gives me a -6. So I have a 1/2 times the absolute value of -6 plus 6 equals 9. Remember, anything inside the absolute value comes out positive, so it's no longer a -6. It is now 1/2 times positive 6. Now we're at 1/2 times 6 plus 6 equals 9. Same thing as last time. I get my 3 from my 1/2 times 6 plus 6 equals 9. Once again, 3 plus 6 equals 9. Check. Both of my solutions work. That's all you have to do for that number 2. So we're going to go ahead and look at this next section. So looking at number 4, it says I have the absolute value of x equals -x, okay? So it asks, is the absolute value equation always, sometimes, or never true? And to explain. So if I look at number 4, so the absolute value of x equals -x. Now at first glance, we know everything that comes out of the absolute value sign should be positive, okay? So for example, let's say I put a 1 in there, so positive 1. Okay. Well, then I get negative times positive 1. So I'm just plugging in that same number. So this time x equals 1. Okay. The absolute value of 1 is 1, and the -1 times 1 is -1. So I'm not true when I'm a positive 1, right? But let's try a -1. So let's say x equals -1. Get the absolute value of -1 equals negative times -1. Anything that goes in my absolute value is spit out as positive, so I get a positive 1. And then the negative times a negative still gets me a positive, so this is also positive 1. So my positive number didn't work, but my negative number worked. So in this case, number 4 gives us a case of sometimes true. And it's sometimes true when x is less than 0. So that's all of my negative numbers. So that's -1 all the way to -infinity. And that's my case where number 4 is true. Then number 4, we're going to look at number 6. Sorry. Okay. So if I have the absolute value of 5w plus 3 equals -4. We know that the absolute value is always positive. I always spit out a positive number. So can I ever have a -4? The answer to that would be no. So at number 6, because my absolute value spit out a negative number, number 6 is a case of never. Okay? Next, we're on to word problems, which are so much fun. The greatest thing in the world, word problems. So we're going to look at number 7, and I'll leave number 8 to you. So number 7 says the amount of pretzels a snack food company fills each bag with must be within 3 pretzels of the 100 pretzels expected per bag. A quality control inspector must ensure the bags are adequately filled. Let P be the number of pretzels in each bag. So let P be the number of pretzels in each bag. The numbers I'm interested in are 100 pretzels expected per bag, and then within 3 pretzels. Okay, so those are the things that I'm curious about, right? So we said P is the total number of pretzels per bag. 100 is the expected number of pretzels per bag. And then we also know that the amount in each bag must be within 3 pretzels of that 100 expected. So we're going to set up an absolute value equation. So I'm going to have some absolute value equals something. In this case, I have to be within 3 pretzels. I must be within 3 pretzels. Okay? So I'm going to set this equal to 3. Now, P is my total number of pretzels, which means I could possibly have more pretzels in all honesty, right? So we're going to say P and then minus my expected number of pretzels, so P minus 100. So all this says is to write our absolute value equation to represent this. In this case, in number 7, our absolute value equation would be the absolute value of P minus 100 equals 3. Like I said, I'll leave number 7 for y'all to kind of figure out. And then next page, I'm going to leave both 1 and 2 for y'all to do, just like our previous assignments where we had to, solve our absolute values and then graph our inequalities at the very end. So reference your previous homework. That's going to help a lot. And then finally, there's 2 more word problems, one of which I'm going to do with you. So let's look at the first one. So it says, pretend that you are allowed to go within 9 miles of the speed limit of 65 miles per hour without getting a ticket. Write an absolute value inequality. Okay, so previously we're looking at equations. Now they want an inequality. Okay? Just write an absolute value inequality that models this situation. So there's a few things that we need to know. I need to know my speed limit of 65 miles per hour, that I'm allowed to go within 9 miles, and then lastly, we're going to go ahead and just use x. So we're going to say x is how much I am going. So let's say my speed, right? Because we need a variable for this. So I already know it's going to be an absolute value inequality. It's going to be my absolute values. In this case, I don't know if it'll be less than, greater than, equal to yet. Let's go ahead and read our question again. So it says within 9 miles. So I can't go over 9 miles. I'm not saying the most I can go is 9 miles. I'm not saying that the least I can go is 9 miles. The most I can go is 9 miles. I can't go more than that. I can possibly go less than that, right? So I'm going to use my less than, and then my 9 miles goes on the outside. Lastly, I have however much I'm going. So my speed in this case, we're not exactly sure. And then lastly, my 65 miles an hour. And your homework, page 1, you've got numbers 3 and 8. And then page 2, you got 1, 2, and then the last word problem. So 5 easy problems and you're done.